All right, so this is assignment 4. Hopefully you've already checked these. I would be checking my answers as I went just to make sure I wasn't doing them all horribly wrong. Find out at the end. So these are the answers. You can pause it right now if you need to take a look. There's a couple more problems down there. So these are all the answers. Check them first. It might have been a silly mistake, parenthesis bracket, something like that. You can figure out yourself. That's best case scenario. But I am going to go over these so then you can have a chance to really figure out where you went wrong, big or small mistakes. But you need to get good at this. So you need to be trying these yourself first. Otherwise, watching me do them is not going to help you get very good to be able to do it on a test on your own. So um, these are linear. So linear, I would just do the way you probably would do back in Algebra 1. Just get the x by itself, kind of normal solving strategy, undo things in reverse order of operations. We do want the answer in interval notation. So if x is less than 7, it's everything to the left of 7 to negative infinity up to 7, including 7. You can never include infinity. So that's your answer. Number 2 is another linear inequality. It's a compound inequality. It's an and that's been combined together, but I wouldn't break it up. I would just try and get this x by itself. So you want to get rid of addition and subtraction first. Whatever you do in the middle, you got to do the left and the right. So, and then we're going to divide by negative 2. Now, whenever you multiply or divide both sides of an inequality by negative, you have to flip the inequality symbols, right? So it's going to be 9. That gets flipped around. That gets flipped around. And usually it probably makes the answer make more sense. Oh, okay. X is between 9 and 12. So the final answer is going to be 9 to 12 bracket parenthesis. That's interval notation, which I require. This one, this is a quadratic. So you want to move everything one side, standard form. So I'm going to subtract an x from both sides, put it second. Then we've got to factor it. Plus 3 minus 4. And find your roots, zero product property. Now we're going to do a line check. Now, any of these to even power, it's going to bounce off the graph, so it's not going to change signs. Neither of them have that scenario, but that's something you have to look for. These are going to be solid dots. If you don't look for that bouncing off the graph issue, it's going to get by you very easily. Test a number. Tell me you should only be testing one region. If you're testing more, my takeoff points, and 2, you're going to get answers that just totally don't make sense. Even if you mess up your test, I want to see that you did everything else correct based off that. I don't want you testing every region. It takes too much time. So I'm going to test 5 far right, positive, which is false, true, false. But writing down what you test is going to help me decide if your first test was wrong or right, and then did you do everything else right. So it's going to be negative 3 to 4, brackets on both sides. Okay, number 4, move everything to one side, standard form, minus 9x, minus 27. Now, before I try rational root theorem, which is kind of a pain, let's try grouping. Group the first 2, group the second 2, x squared, x plus 3, take a negative 9 out, x plus 3. So whatever sign is in front of that first term, anytime you factor, you usually factor that out of everything. And if you get the same thing, then that means grouping is going to work. So we factor that out, and then whatever's left, we should keep factoring. So you get a quadratic. Usually a cubic, you factor one thing out, and you got a quadratic. Now this is just difference of squares. Easy. Now I'm going to rewrite this. If there's any repeated factors, let's write them together with an exponent. And then I think I'll make it easier to realize, oh, that's one that I got to make sure is going to bounce off the graph, right? So keep track of that. I'm going to do a line check. These are solid dots. And this guy's going to bounce off. We can test a number, x equals 4. And it's easiest to check these in the factored version because then you're just deciding positive or negative. Instead of trying to get numbers and stuff, that's way harder. Positive is true. False stays false. Now, the The mistake people are going to make on their next test is they're going to say, oh yeah, 3 to positive infinity. They're going to feel really good about it. I feel like I made a mistake though. 4, 4, 4. Oh, when I tested 4, I should have wrote false. So then this should be true, and then this should be true. So my test messed up. I did everything else right, but this should be the answer. We can go negative infinity to positive 3 bracket. Don't break it up. It's a solid dot. I'm sure that other issue I was about to try and explain will come up on another problem. This one is all very conveniently on one side compared to 0, already factored for you. They've done a lot of work for you. Don't miss the x equals 0 is a root. Okay, now this one, you got to watch out for in this one, right? So this is a fast problem. You should love them like this. These are all solid dots, -5, -2, put a little star next to it, 0, and 1. And 1 needs a little star next to it. Now we're going to test far right. You can test far left or in the middle if you want. I just think far right is the easiest. 2, positive, 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 which is false, stays false, starts flipping, true, stays true, begins flipping again. So the answer is -5 to 0. And the mistake people are going to make is they're going to say, that's it. Well, this guy's an answer, union, curly braces, 1. It's a lone solution all by itself. It's not interval. So this is called set notation. We're just putting a single number in there. Okay? So don't miss that guy. First of all, don't miss that it's bouncing off the graph. Now, the new kind of problems were these rational inequalities. You want to move everything one side, get in a single fraction, factor it. Now, this guy's already done. So this one's an easier one. This one's ready to go. No cross multiplying on these. Now, we're going to do a line check, and we're going to put -3 on there and -2. Now, -2 is going to be a solid dot because of the or equals 2. But -3, anything from the bottom ever is going to be open dot because that's the vertical asymptote. It's division by 0 is not allowed. The function, if you graph it, doesn't exist there. So you can't tell me that this is less than 0 where it doesn't exist. Okay? Test x equals 0. Positive over positive is positive, which is not negative. So that's false, true, false. And the answer is -3, -2, parenthesis, bracket, interval notation. All right, next one is ready to go. X equals 4, x equals -2. Now this has that even power, so same issue as before. It's going to bounce off the graph. It's not going to go through it like normal x-intercepts. It's going to be like, here's the x-axis. I'm going to barely hit it. So it's going to stay positive or negative on both sides, which is going to keep this true or false on both sides. So line check. -2 is an open dot. Positive 4 is an open dot because this time there's no word equals to. The top ones are dependent on that. You can test a value. X equals 5. Positive, 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 true. Now remember this 4 guy stays true, then starts switching back and forth. So the answer is -2 to 4. Union 4 to positive infinity. You got to break it up at 4 because that's an open dot. If it's a solid dot, you wouldn't have to break it up. Okay, this one. Now, this one's going to take some more work because it doesn't make sense to start finding roots if it's not equal to 0 because those aren't roots. So you're going to get everything on one side. Do not cross multiply. Do not cross multiply. Give these guys least common denominators because I want one big fraction. So 2x minus 8. Now you got to distribute this negative, so it's -x plus 3. Okay. Combine like terms. 1x minus 5 over x minus 3 greater than or equals 0. So x equals 5 and x equals 3 are your roots. You don't have to factor this time. It worked out pretty nice. Bottom's going to be the 3 from the bottom is going to be open dot. The 5 from the top is going to be a solid dot. Test a value. X equals 6. Positive, positive, which is true, false, true. -infinity to 3. union bracket 5 to positive infinity, always parentheses on infinity. Okay? All right. So hopefully you're starting to get the hang of these. You got to move everything one side first. That's always the strategy on these, except for the linear inequalities. Move everything one side, get least common denominator. Be careful. Show some mark if you have to. Okay, this negative has to be distributed, so we're going to get x squared minus x plus 2 on the top. On the bottom, leave the bottom factored. They should be the same. Leave it factored. Factor the top now after you combine like terms. X minus 2x plus 1. No, it's got to be two negatives. Oh, we can't factor this. Does that mean no solution? Now the bottom, got x equals 0, x equals 2. But the top, I got to do quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. You guys should know this. All over 2 times a. And that just means we're going to get irrational roots, but our answers could be irrational. That's fine. That's real. 1 plus or minus the square root of 1 minus 8 over 2 equals 1 plus or minus the square root of negative 7 over 2. So right now at this point you could bail because you're getting imaginary answers. Okay? So that's fine. It has imaginary roots, but those aren't going to show up as x-intercepts of the graph, which is what we're trying to find. So really, there's no x-intercepts of this graph at all. So we can do a line check just with these values, 0 and 2. We're going to test a value, x equals, so it has some vertical asymptotes. So test x equals 3, which is positive, 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 which is false, true, false. 0 to 2, parentheses, that's your answer. Okay? I got to see the work that you look for those, though. Because just because you're doing quadratic formula doesn't mean they're going to be imaginary every time. And I'm not going to be convinced that you somehow did that in your head. Okay? Do not cross multiply. Do not cross multiply. Do not cross multiply. So we're going to move everything in one side. Using algebra, subtract this whole thing over to the other side. Compare to 0. Give these guys least common denominators. Now, you can start doing some of this in your head if you feel comfortable. Like this is going to get multiplied by an x plus 2. So that's going to be x squared plus 2x. This is going to get multiplied by an x plus 5. Now, I'm not comfortable enough yet. I'm going to do the negative afterwards because that has to subtract all of it. But it's going to give you x squared, 3x and a 5x is an 8x in the middle, and a 15. Don't lose the bottom. Don't multiply the bottom out either. So you got to distribute this. So the x squareds actually go away. And you get negative 6x minus 15. And keep that inequality going. And then we can factor this if you want. So you can negative 3 out. 2x minus plus 5. That didn't necessarily do a whole lot for us, but whatever. So x equals negative 5 halves from the top, x equals negative 5, and x equals negative 2 from the bottom. So we're going to do a line check. Negative 5 is furthest to the left, open dot. Negative 5 halves is negative 2.5. That's next, solid dot. And then negative 2 is an open dot. So I'm going to test x equals 0. So that's going to give me positive, 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 but then there's a negative on the end, which makes it false right here. True, false, true. Okay, so the answer is negative infinity, negative 5. Union, bracket, negative 5 halves, or negative 2.5 to negative 2, parenthesis. That's it. Okay. All right, next one. Move everything on one side. All right, given least common denominator, 6x minus, I'm going to multiply this by an x minus 5, right? So it's going to be minus x squared plus 5x. Bottom, least common denominator. Don't multiply it out. I'm going to rewrite this. Standard form, negative x squared plus 11x. And then when we factor this, take a negative x out, and then that would be an x minus 11 on the inside. You got to factor the negative out too. So I think that's good. So we're going to get x equals 5 on the bottom, x equals 0 on the top, x equals 11 on the top. So your line check, I'll just squeeze it in over here. Your line check is going to be, I gotta need something to block this light. Okay, by the way, my trick for blocking light is really high tech. It's a pizza box. That is pretty clean. Otherwise, I'd be wanting pizza right now. Okay, line check. What's the furthest to the left? 0 is an open dot. 5 is an open dot. 11 is an open dot. They're all open dots, right? I'm going to test. I like test far right. 12, positive, positive, positive. But then there's this extra negative that makes it all negative, which makes it true. False, true, false. Any even powers on any of those roots? Nope. So the answer is 0 to 5. And 11 to positive infinity, union. So we're always using union right now on these because we're saying these answers or these answers. If you use intersection, it would be, if you simplified it, it'd be nothing, no answers. Okay, number 12, it's cubic. We've seen some cubics lately. Polynomial, we like to try grouping, right? It's all on one side, equals 0, standard form. So we could try grouping. We could take a 4x squared on both of those, x plus 2. Could we take a minus 3 out of this? It would be 17x minus 15. Now, for grouping to work, these have to be the same, and they're not. So grouping is not going to work. Sorry. So now we get to go to our friend. I know you guys consider it your friend, rational root theorem, P over Q's. Now, the P's come from here. The Q's come from here, right? So we can just start making a list of, well, here's the deal. Plus or minus 1, plus or minus 3, plus or minus 5 times 9, plus or minus 9, plus or minus 15, plus or minus 45, right? I think those are all the roots of this. Now we got to divide them by plus or minus 1, plus or minus 2, plus or minus 4. So this is going to be a list of 6, 18, 36 different possible numbers. But here's the deal. It's got to be something nice. Hopefully it's something nice. So let's just think of the plus or minus 1, and not the plus or minus 2 or plus or minus 4 yet, unless one of these nice ones, when divided by plus or minus 1, which is the same list, doesn't work. Hopefully it's something nice. So let's try positive 1. 4 plus 8 is 12. Plus 45 is 57. Nope. How about negative 1? Negative 1, this would be negative 4. This would be negative 55. And this would be positive 53. Close, but nope. So we got to try positive 3. 3, this one's kind of hard. See, 3 times 3 times 3 is 27. 54, 108. 108. I'm usually trying to do this in my head. 72 minus 153 and plus 45. Oh, that's positive 3. 153. Nope, that doesn't work. How about negative 3? Ooh, well, that's going to be negative 108 plus 72 still, plus 153 plus 45. Does that add up to 0? Nope. Ugh. How about 5? 5 times 5 times 5 times 5 is 125, so that would be 250. That would be 500 plus 8 times 5 is 200 minus 255 plus 45. Does that add up to 0? No. How about negative 5? I mean, these are the easy ones, by the way, guys. This one's a tough one. Negative 5 would be negative 125, so that's going to be negative 500 plus 200 still, right? plus 255 plus 45. So that's going to be 305. Oh, yeah, that one adds up to 0. It's okay. So even though that seemed a little torturous, at least we got it on the 6th number and not like some of these weird fractions later on, which it could be. So negative 5. Now, there might be other roots. We don't want to find them that way if we can avoid it. So let's divide this out first and then at least make the list smaller and at least maybe get a quadratic that we can just factor a normal way. Put the coefficients 4, 8, negative 51, and 45. If there's any missing, you got to put 0. So this is called synthetic division now. Rational root theorem and synthetic division are two different things. We could use long division on polynomials too, but synthetic division is a cool trick. Drop that number. Negative 5 times 4 is negative 20. Add those together, multiply. That's going to be 90, positive 90. So then that would leave you with, I don't know, I feel like I made a mistake somewhere because this should be a 0 when I'm done. So if I see that it looks like it's not going to be 0, then I go back and try and figure out if I did something wrong. Double checking my work. Oh, this is negative 12. Crap. 60. I'm showing you, I made a mistake and that's how I figured it out. I saw it coming. I went back and figured it out. Because at the end, you should get negative 45. Now, if you're not, don't fake it because I'm going to know that is wrong and I'm going to deem you more points. At least if you went with your mistake, then you get more credit for doing the rest of it correct. If you start magically changing answers, that's just another mistake to me on top of the mistake you had before. And I'll be able to tell, obviously. So x plus 5 is what you just divided out. You're like, oh, but that's negative 5. Yeah, but that's the root you would get from this, right? This is the root. This is the factor that it comes from. This is going to be 4x squared minus 12x plus 9. So you're going to put the x's in. They're going to start at a power 1 less than the original one. If you divide a first degree polynomial out of a third degree polynomial, it's going to be a second degree polynomial now. Now let's keep that less than or equal 0 over here. Now this, I'm going to try and factor it. I'm not going to use synthetic for it for sure. So is it 4x and 4x? Or 4x and 1x? Or is it going to be 2x and 2x? Well, it's got to be factors of 9. They got to both be negative for sure to get a positive 9 and give you a negative number in the middle. So it'd be, if you put 9 here and 1 here, that'd be 37. 9 here and 1 here, that would be 13. We need 12. 3 and 3, that would be 12, and 3 is 15. So I don't think it's that. So I think I got to go with 2 and 2. And now try 9 and 1. So that'd be 18. That'd be 20. Or 3 and 3 would be 6 and 6 would give you 12x. Perfect. Okay, so that was a little harder on the algebra 1 level. Right there, right? Now, this is a double root now. So that's one of those star guys. Right? You can rewrite it, 2x minus 3 squared. I'm going to go ahead and just skip that step. Now we're going to do a line check. So this is going to be, these are solid dots, negative 5 and 3 halves. We're going to put a star next to that. Test a value, x equals 2. Positive, 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 which is false, stays false. Now starts turning to true. Your answer is negative infinity, negative 5, bracket. Do not forget the 3 halves. It's a lone answer. So union, curly braces. Okay? I guarantee I'm going to put something like that on your next test with at least one problem. Multiple problems that have the bouncing happen. At least a problem where you get a lone answer. Now, if that was an open dot, you wouldn't put it. Okay, one more rational one. Move everything to one side. Compared to 0. Least common denominator. Hopefully you guys are getting the hang of these steps. All right, this is so we're going to get x squared minus 8x minus 24 if you distribute this negative 8 to all that over x plus 3, leave the bottom factored. Factor the top, x and x. 4 times 6, 2 times 12, don't know. Do any of those work? It's got to be positive, negative. Plus 4 minus 6. No. The bigger one should be the negative one, so you end up with negatives when you're done. 2 times 12. Nope, that gives you negative 10. 1 24, gives you negative 23. So we can't factor the top, which is fine. We can factor the bottom, but we got to use quadratic formula. So we're going to do x equals, and so far I feel like the couple of quadratic formulas we've done ended up imaginary, but you can't just assume that. Take off points even if they do, if you don't show the work. Negative b plus or minus the square root of b squared minus 4ac. It's really easy to make mistakes in quadratic formula, so be very careful. All over 2a. So that's going to be positive 8 plus or minus the square root of 64 plus 96. 8 plus or minus, that's going to be 160. Okay, now if this was a nice square root, that means you could have factored originally. If it's not, then that's why you're doing this. It's irrational. So 2 times 80, 2 times 40, 2 times 20, 2 times 10, 2 times 5. So this is what I do. A little do a factory. And every pair of common factors, that's a perfect square you can take out. So it's going to be plus or minus. Now, I get a 2 for that, another 2 for that. They multiply each other to give you 4. And on the inside, you have a square root of 10 left over. You guys should know how to simplify radicals. Now, this 2 has to divide both of these terms. Don't just magically reduce the 2 with the 8 and make it a 4. This guy gets the 2 also. So it's going to be 4 plus or minus 2 root 10. So you get two answers, 4 plus 2 root 10 and 4 minus 2 root 10. Now, you should be able to do these without a calculator most of the time. Can you estimate that? Square root of 10 is between square root of 9 and 16. So it's between 3 and 4. It's close to 3. So I'm going to say it's about 3.1. So I'm going to say this is 4 plus 6.2 is 10.2. This one is 4 minus 6.2. So that's about like negative 2.2. And that should be good enough, hopefully, for you to line things up in the right spots on your number line. That's the only thing you're really worried about here. I don't want these in my answers. I want these in my answers. So you should put these in your number line too. So what's the furthest to the left? Negative 3 from the bottom is an open dot. And then this negative answer, which is 4 minus 2 root 10, right? That's negative. And then 0, and these are all open even on the top. And then 0, and then the positive one, 4 plus 2 root 10. So put these on here. I just wrote these things to make sure I put them in the right spots. Now I'm going to test a value. This is also another thing that you might say. Well, you might just say, you know what, at this point, this is such a big number. If I plug 11 in, it's going to be kind of hard to verify because it's not factored. I might just test something like x equals 1. You know, just remember which section it's in. So if I plug 1 in here, 1 minus 8 is negative 7. That's negative over positive to negative, which is true. And then it goes outwards in both directions. False, false, true, false. And so your final answer is negative 3 to 4 minus 2 root 10, parentheses, union 0 to 4 plus 2 root 10, parentheses. That was a hard problem, not because of new stuff. The hard part of that was the algebra 1, right? Getting those roots. So there you go. That's all the work for this homework. So hopefully now you feel very confident. You figured out what you're doing, and you should have, next time, hopefully you can get them right on your own. All right.